Imagine you're aboard a spacecraft, and Jupiter is filling your view screen. From a distance, it almost looks peaceful. Those swirling bands of cream and burnt orange. The famous red spot sitting there like a painted eye. It's genuinely beautiful. The kind of image you'd frame and hang on a wall. But as you close in, something shifts. An alarm cuts through the cabin. Then another. Your instruments start behaving strangely, readings spiking and dropping, screens flickering. And then it hits you. You're not approaching a planet. You're approaching something that doesn't want you anywhere near it. Jupiter is not the gentle giant we were taught about in school. It's not a quiet, distant neighbor minding its own business at the edge of the inner solar system. It's a cosmic horror story written in gas and gravity, and it's been hiding in plain sight for billions of years. By the time we're done here, you'll never look at that bright dot in the night sky the same way again. Let's start with the basics, because most people genuinely don't grasp what we're dealing with when we talk about Jupiter's size. You could fit more than 1,300 Earths inside Jupiter. That number is so large it almost loses meaning, so think about it this way instead. Take every single planet in the solar system. Mercury, Venus, Earth, Mars, Saturn, Uranus, Neptune, all of them. Add in every moon. Every asteroid. Every chunk of rock and ice drifting through space. Add all of it together. Jupiter still outweighs the entire collection twice over. It's not just the biggest thing in our solar system after the Sun. It's bigger than everything else combined, and then some. But here's where it starts to get genuinely unsettling. Jupiter almost became a star. If it had accumulated just 80 times more mass during the early chaos of the solar system's formation, nuclear fusion would have ignited in its core. We wouldn't be talking about a planet. We'd be talking about a second sun. Earth would exist inside a binary star system, assuming it had managed to form at all, which is far from guaranteed. The conditions for a planet like ours, sitting at exactly the right distance, with exactly the right temperature range, might never have existed. Instead, we got something that might actually be more dangerous. A world with no solid ground, pressures that would crush anything we've ever built, and a gravitational pull so overwhelming it has been quietly dictating the fate of the solar system for 4.5 billion years. Zoom into Jupiter's atmosphere, and what you're seeing isn't weather in any sense we'd recognize. Weather is what happens when air moves around. What happens on Jupiter is something closer to permanent, planet-scale violence. The Great Red Spot is the most famous example. That swirling reddish oval has been spinning continuously for at least 400 years, possibly much longer. We don't know exactly when it started because it was already raging when humans first pointed telescopes at the sky. This single storm is wide enough to swallow the entire Earth with room left over around the edges. Wind speeds along its outer boundary exceed 400 kilometers per hour. And that's considered calm by Jupiter's standards. Deeper in the atmosphere, jet streams tear across the planet at over 600 kilometers per hour. These aren't strong gusts. They're rivers of gas moving faster than the speed of sound travels through air on Earth. If you were somehow standing inside one of those jet streams, the force wouldn't push you. It would disintegrate you. But even that isn't the scariest part of Jupiter's atmosphere. The scariest part is what happens when you go deeper. Jupiter has no surface. There is no ground. The atmosphere just keeps going, getting thicker and denser and more crushing with every kilometer down. The pressure builds and builds until something extraordinary happens. Hydrogen, the lightest and most common element in the universe, the same gas that makes up a large chunk of the air we breathe, gets squeezed so hard that it stops being a gas. It stops being a liquid in any normal sense. It becomes something called liquid metallic hydrogen. A state of matter that doesn't exist anywhere naturally on Earth. A state of matter we can barely recreate in laboratories for fractions of a second. Down in Jupiter's interior, it exists in vast, churning oceans. And those oceans are responsible for the thing that makes Jupiter truly deadly. Earth has a magnetic field. You probably know this. It's what makes compasses work, and more importantly, it's the invisible shield that deflects the constant stream of charged particles pouring off the sun. Without it, solar radiation would strip away our atmosphere and sterilize the surface. Our magnetic field is, in a very literal sense, one of the reasons life exists here. Jupiter has a magnetic field too. The difference is scale. Jupiter's magnetic field is roughly 20,000 times stronger than Earth's. If you could see it with your eyes, it would appear larger in the sky than the full moon does from Earth's surface. It stretches millions of kilometers out into space in every direction, reaching so far that its outer boundary actually extends towards Saturn's orbit. It is the largest structure in the entire solar system, and it is completely invisible. You might think a stronger magnetic field means better protection. More shielding. A safer environment. It means the opposite. Jupiter's magnetic field acts like an enormous particle accelerator. It captures charged particles from the solar wind and the volcanic activity of its moons, then funnels them, spins them up, and accelerates them to speeds approaching the speed of light. These particles get trapped in radiation belts surrounding the planet, dense invisible rings of lethal energy that would kill an unprotected human being in minutes. Not hours. Not days. Minutes. When NASA engineers designed the Juno spacecraft, they built a special titanium vault around its most critical electronics. A solid metal box weighing around 200 kilograms, designed specifically to shield the instruments from Jupiter's radiation. And even with that vault, Juno can only make close approaches to Jupiter for a few hours before the radiation starts threatening to destroy its systems. The spacecraft has to retreat, recover, and wait before it can go back in. The Galileo probe, which deliberately plunged into Jupiter's atmosphere in 1995, absorbed a radiation dose during its approach equivalent to 25 million dental X-rays before the pressure finally crushed it and the planet swallowed it whole. This is the environment around Jupiter. And we haven't even talked about what it does to the neighborhood. Jupiter doesn't just sit there being dangerous. It actively reshapes everything around it. Scientists believe that in the early solar system, Jupiter didn't form where it sits today. It formed further out and then migrated inward, drifting closer to the Sun before eventually being pulled back outward by Saturn's gravity. This migration is described in something called the Grand Tack hypothesis, and if it's accurate, the consequences were enormous. As Jupiter moved inward, its gravity scattered material across the inner solar system like a wrecking ball rolling through a construction site. Mars, which sits right next to the asteroid belt, never grew to its full potential because Jupiter kept disrupting the material it would have needed. Scientists estimate Mars should be roughly the same size as Earth. Instead, it's about 1/10 of our mass. Jupiter stunted its growth. The asteroid belt itself isn't the remains of a destroyed planet, which is a surprisingly common misconception. It's the remains of a planet that never got to form. All that material, billions of rocks and boulders drifting in a band between Mars and Jupiter, it was supposed to become something. Jupiter wouldn't let it. And this gravitational influence never stopped. It's still happening right now. Comets and asteroids drifting through the solar system regularly get caught by Jupiter's gravity. Some get pulled in and absorbed. Some get slung toward the inner solar system. Some get deflected out into deep space, exiled permanently. Jupiter is constantly sorting through the solar system's debris, deciding what stays and what goes. In 1994, we got to watch this process up close in one of the most spectacular astronomical events in recorded history. A comet called Shoemaker-Levy 9 got too close to Jupiter and was torn apart by tidal forces into 21 separate fragments. Then, over the course of a week, those fragments crashed into Jupiter one by one at around 60 kilometers per second. Each impact left a dark bruise on Jupiter's atmosphere larger than Earth. The energy released across all 21 impacts was equivalent to hundreds of millions of nuclear weapons going off simultaneously. If that comet had been aimed at Earth instead of Jupiter, the conversation about what happened to the dinosaurs would have a sequel. Some researchers argue that Jupiter's gravity actually protects Earth by hoovering up these dangerous objects before they reach us. Others point out that Jupiter also deflects things toward us that would otherwise have missed entirely. The honest answer is that Jupiter both increases and decreases our risk depending on the specific trajectory of any given object. It's not our protector. It's just doing what gravity does, indifferent to whether the results are good or bad for us. You might think that at least Jupiter's moons offer some respite. After all, Europa has a liquid ocean beneath its ice. Ganymede is bigger than Mercury. These are worlds in their own right, and scientists genuinely believe some of them might harbor conditions suitable for life. But living near Jupiter means living inside its radiation environment. And Jupiter's moons don't get an exemption. Io is the closest of the 4 large moons, and it is without question the most geologically violent place in the solar system. It's covered in active volcanoes, erupting constantly, reshaping its surface so rapidly that craters barely get a chance to form before they're buried under fresh lava. This isn't driven by internal heat the way Earth's volcanism is. It's driven by Jupiter's gravity literally squeezing and flexing the moon as it orbits, generating friction and heat deep in the rock. Io is being kneaded like dough, and the result is a world that looks like it's permanently on fire. Europa, the moon that excites astrobiologists most, orbits deep inside Jupiter's radiation belts. The surface of Europa receives a radiation dose that would be instantly lethal to any life as we know it. Any future mission that lands on Europa will need heavily shielded electronics just to survive long enough to operate. And if scientists want to search for life in that subsurface ocean, the spacecraft will need to drill through kilometers of ice while the radiation steadily attacks its systems from above. Ganymede has something no other moon in the solar system possesses. Its own magnetic field. A small bubble of protection generated from within. And even that isn't enough to fully shield it from what Jupiter throws at it. These aren't safe harbors. They're captive worlds, locked in orbit around something that makes their existence fundamentally hostile. Take a step back and look at the full picture. Jupiter isn't dangerous in one specific way that you could theoretically engineer around. It's dangerous in every way at the same time. The pressure would crush you. The radiation would kill you. The gravity would trap you. The storms would tear you apart. The magnetic field would fry your electronics. There is no angle of approach, no orbit, no altitude, no engineering solution that makes Jupiter safe. Every mission we've ever sent there has been running a timer from the moment it arrived, counting down to the moment the planet wins. And here's the part that tends to get lost in the conversation about exploration and discovery. Jupiter is still actively shaping the solar system right now, in real time, on timescales too slow for us to watch but fast enough to matter. Its gravity nudges asteroid orbits. It redirects comets. It influences the subtle motion of the Sun itself. In a very real sense, Jupiter is still deciding which objects in this solar system have a future and which ones don't. We keep sending spacecraft there anyway, and we should, because the terrifying things about Jupiter are also the most scientifically interesting things about it. That liquid metallic hydrogen interior tells us things about how gas giants form throughout the universe. The radiation environment around Jupiter is a natural laboratory for studying physics we can't easily replicate on Earth. The moons, hostile as they are, remain the most promising places in the solar system to look for life beyond our own planet. The data coming back from Juno has already rewritten parts of what we thought we knew. Jupiter's core isn't the compact solid ball that older models predicted. It's a diffuse, fuzzy region, spread across a surprisingly large volume of the planet's interior, possibly still incorporating material from impacts that happened billions of years ago. The storms we see on the surface aren't shallow weather patterns sitting on top of calmer air below. They extend hundreds of kilometers deep into the planet. And Jupiter's auroras, the brilliant light shows at its poles, are powered partly by material blasted into space by Io's volcanoes, which gets ionized and swept along magnetic field lines until it glows. They're bigger and more energetic than anything Earth produces, and they're driven by a chain of events that connects the volcanic surface of one moon to the magnetic architecture of an entire planet. But for all of that knowledge, all of that hard-won data, Jupiter remains something we can study from a cautious distance and nothing more. We will never walk on it. There's no surface to walk on. We will never build a research station in its atmosphere. The pressures and radiation make that a permanent impossibility, not a current technical limitation. Even our robots can only visit briefly before the planet starts winning. Jupiter represents something rare in human experience. A hard boundary. A place that exists entirely outside the range of human habitation, not because we haven't figured out the engineering yet, but because the physics simply don't allow it. It's a reminder, a fairly blunt one, that the universe was not arranged with our survival in mind. Jupiter has been here for 4.5 billion years. It was burning through comets and reshaping planetary orbits long before the first cell divided in Earth's early oceans. It will still be here, still violent, still hungry, still indifferent, long after every trace of humanity has faded from this planet. When you look up on a clear night and spot Jupiter as a steady bright point of light, you're not seeing a peaceful gas giant hanging quietly in the dark. You're looking at a storm that has been raging since before the dinosaurs existed. A radiation source that would end a human life in minutes. A gravitational force that has been quietly deciding the fate of worlds for longer than complex life has existed on Earth. Jupiter isn't the king of the planets because it earned the title through nobility or grace. It's the king because nothing else lasted long enough to take it from it.